So the projectile motion practice worksheet, a few things you have to pay attention to when you first get started on this worksheet. The helpful notes on the side over here, okay? Y is vertical, so you get this little visual right here with the Y. We're talking about vertical when we say Y. X is horizontal, okay? Gravity. What's the number for gravity? Negative 9.8. For this worksheet, we're going to round it to 10. It's just going to make the math a whole lot easier. You actually can do this without a calculator. All right, that's how easy the math is going to be. So, believe me, you want to be able to do that. However, on any quiz, it's going to be like 9.8. CBA 9.8. But on this worksheet, we're going to make it negative 10. Okay? Remember, up is positive and down is negative. All right? We're talking about velocity. Okay? Up is positive, down is negative. All right, so we're starting off here with a diagram. Remember, when we're talking about projectile motion, okay? Projectile motion, talking about trajectory, that nice parabolic shaped trajectory, okay? Something goes up, gets to the apex, and comes back down to the ground, okay? Projectile motion. All right, so in projectile motion, we have here t equals 0s, 0 seconds. We're going to label these. Each position there is at 1 second. So we have a t equals 1 second, t equals 2 seconds, t equals 3 seconds. Right here at the top, t equals 4 seconds. Right there at the very, very top, the highest it can get. What do we call that?
Apex.
The apex. So our projectile reaches the apex at 4 seconds. Okay? Now, as it goes up, it decelerates. All right, it goes slower and slower and slower. As it comes back down, it's going to go faster and faster and faster. Okay? Gravity is what slows it down as it goes up and what speeds it up as it goes down. Okay? Now, few visuals here. We are going to, step 1, draw the position of the ball on the drawing at times 5, 6, 7, and 8 seconds. Okay? So, we have 0 through 4 done. How are you going to do 5 through 8? Okay? So, with the parabola, there's your easiest hint. With the parabola, what can you tell them about one side of the parabola and the other side of the parabola? They reflect. It's a mirror image. Okay? So that is your first easy hint and clue. All right? Watch this. At 0 seconds, going along the x-axis. At 1 second, draw a little tick mark down at the bottom there. 2 seconds, where that is, draw a little tick mark at the bottom. 3 seconds, all the way down to the x-axis. Tick mark. 4 seconds, all the way down to the x-axis. Do you see a pattern there? All right? See that every 2 right there? That is demonstrating that horizontal motion, which is a constant velocity. Okay? So we have a constant horizontal velocity. Now, as we're going up, we are decelerating. As we're coming down, we are accelerating. Okay? Given that information, the next second's going to be 5 seconds. Where horizontally, what height is 5 seconds, is the projectile going to be at 5 seconds? Is it going to be down here? Is it going to be all the way at the top? Where's it going to be? All right. It's going to be just as high as the 3 seconds. All right? But it's not going to be right here. It's going to be right there because it's also still moving forward. Okay? And label it t equals 5 seconds. On your own, right now, go ahead and do 6, 7, 8, 9, 6, 7, 8 seconds. And be sure to label them 6, 7, and 8.
You see how that dot is right in between those two crosses? You have that like between lines, it needs to be right across. So you see like 1, 2, needs to be right there. Where those two lines cross together, that dot is right there. Okay, and then from there you're gonna go over 2. That dot is right there, so you have that completely off color. And now it's off as well. See how they go over 2? 1, 2, 3, 4 on that one. Okay? So you're gonna just go 2 more from there. 2. So it needs to be right here. Well, actually, you go further over. Okay. Right there. And then you're gonna go down to this one and you go over 1, 2. So 7 seconds right there. And it takes you 8 seconds to walk. Label them.
5, 7, 6, 7, 7.
All right, so you're going to go down vertically to the same height as a 2 second over 2. There's your 6 seconds. T equals 6 seconds. Go down to the height of 1, the 1 second, and just go over 2. So that's T equals 7 seconds. And you're going to go all the way down to the height of the 0 and go over just 2, and there's your 8 seconds. All right? You do not go all the way to the end of the graph. All right? Okay. Number 2. Use the picture and the given data to fill in the chart below. This is the given data, the 40 and the 16. Okay? Looking at that 40 and 16 carefully, you have a VIY. You've never seen that before. What does V stand for? velocity. All right, what does I stand for? Initial. What does Y stand for? Vertical. Okay? So we have the initial vertical velocity of the projectile. Okay? Vix is going to be, again, velocity. The initial velocity, but horizontal, because X stands for horizontal. Okay, so now we have the horizontal initial velocity. All right, we got a data table to fill in. Vx and Vy at each second. X stands for horizontal. Y stands for vertical. Okay, and it's asking for velocity. Okay, so horizontal velocity. Let's start with horizontal velocity. What is the horizontal velocity of the projectile at 0 seconds? When the projectile is right there, what's its horizontal velocity? So at time 0, what am I really asking for? I'm asking for the initial velocity, aren't I? What's the initial horizontal velocity?
Oh no, 16.
16. Now, what did we learn about horizontal velocity of projectiles? Okay, open your journals. Right there, projectile motion, page 19. What do you know about horizontal motion of projectiles? Constant what? Constant velocity. Look there at your diagram in your notes with the cannonball. Vx, your horizontal velocity. 20, 20, 20, 20, 20, 20. It is constant. All right. So, at 1 second, so from 0 to 1 second, horizontally it moved those two. From 1 to 2, it moved the same space. From 2 to 3, the same space. It moves the same distance or horizontal displacement every second. So is the velocity going to change?
Nope.
No, it's not. So from 0 to 1 second, what is now the horizontal velocity? 16. And because it's at a constant velocity, at 2 seconds, the velocity is going to be 16. And we're looking at the horizontal velocity of a projectile, and the horizontal velocity of a projectile a second later is still going to be 16. Because we're dealing with a constant velocity in the horizontal direction, we now have a velocity of 16 at 4 seconds. And at 5 seconds, the velocity is still going to be? Do we see the pattern? That doesn't change. That horizontal velocity does not change. Horizontally, the position of that ball spaces out evenly. Constant velocity. Yes?
Yep.
All right. Vertical velocity. Is the vertical velocity going to be constant? No. Why? What causes the velocity? All right. What's causing the velocity to change? Gravity. All right. So, vertical velocity at time 0, aka initial vertical velocity. What's it going to be? 40. Now, is it going up or is it going down initially? Up. So it's going to be positive or negative? Positive. All right. Now, 1 second later, when the projectile's right there, is it going to be going the same velocity, faster, or slower?
Lower.
All right, it's going up. As the projectiles go up, what happens to their velocity?
Slows down.
Slows down, decreases. So it's going to be smaller than 40. But how much smaller? What's making it slow down?
Gravity.
What's our value for gravity in this worksheet?
10.
Negative 10. Decrease by 10. 10, it's not going to be 30. At 2 seconds, is it going to be going 30 faster or slower? Even slower. So going from 30 to 20, decreasing by 10. From 2 to 3 seconds, is the velocity going to change? By how much? By negative 10. So we're going to end up with 10. At 4 seconds, 0. At 5 seconds, negative 10? Now wait a second. What the heck? What do you mean by negative?
It's going down.
Oh, down means negative. Is the ball going down right there? Yes, it is. Negative 10 it is. How about at 6 seconds? Negative 20. Ooh. At 7 seconds? Negative 30. And at 8 seconds, right before it splatters into the ground? Negative 40. Okay? So give yourself a little note here on the side. Negative because it's going down. All right? Negative because it's going down. Make sense? Yeah? All right. To be able to move on, the first observation we need to do, we need to pay attention here to this horizontal and vertical velocity. Notice the horizontal velocity, that constant velocity, is not affected by gravity, but the vertical velocity is affected by gravity, okay? This is an essential detail for you to recognize in order to be able to choose the formula you're going to use, okay? So the vertical velocity is affected by gravity, so I want you to put a G under there, G for gravity, all right? Now look at your two formulas. These two formulas, even though they look very different, actually have a lot in common. They both have displacement, they both have velocity, and they both have time. The one thing that is different is gravity. Gravity is in one of these formulas but not in the other. So with that same color, I want you to highlight the G in gravity, and I want you to circle our value for gravity of negative 10. Okay, all in that same color. When we're dealing with this formula, we're dealing with gravity. So therefore, we're dealing with vertical velocity because gravity is involved in the vertical movement of an object. Gravity does not affect the horizontal motion, so we'll be using the regular velocity formula for that. Okay, let's look at the first question. It says calculate the vertical displacement or height at 2 seconds. All right, so what we need, focus on that question, vertical displacement. Take a new color and highlight that, vertical displacement and the 2 seconds. What is that question actually asking? Well, find the location of the projectile at 2 seconds. The vertical displacement. What it's asking is this. How high, that vertical displacement there, how high does that ball or that projectile get at 2 seconds? How high up is it at 2 seconds? That's what the question's asking. Now, gravity. Is gravity involved in vertical displacement? Yes or no? Yes, it is, because of the vertical. So we know we're dealing with gravity. So we're going to use this formula. The delta D equals VI delta T plus 1/2 G delta T squared. Okay, so if you read the question carefully, displacement is what we're trying to solve for. Okay, if you don't remember, this symbol right here, that's the symbol for displacement. Okay, so displacement is what we want. The formula is already set up to solve for that, so we're good to go. Now, first we need an initial velocity. Well, if you pay close attention to the data you've been given, we have two different initial velocities to choose from. Considering we want the vertical displacement, we need the vertical initial velocity. So this number right here, we need the vertical. Okay? So vertical, we're going to do that 40. Multiplying by the change in time. In this situation, the change in time is the 2 seconds. Okay? So 2 is the change in time. Plus 1/2, write that down as 0.5, multiplied by g. Alright? -10. For this one, we're doing -10 meters per second squared. Do not forget the negative. Alright? And then again, delta t, 2 seconds, and square it. Don't forget the square. Do not forget to square it, otherwise you're in big trouble. You get really wrong numbers. Okay? Punch that all into the calculator just as it is. No parentheses or anything needed. So 40 multiplied by 2 plus 0.5 multiplied by -10 multiplied by 2 squared. There's your square button right next to the 7. Okay? Enter. 60. 60 what? Well, again, go back to the question. What was it asking for? It was asking to figure out this height, this vertical displacement, as we measured in meters. Okay? Now calculate the vertical displacement at 4 seconds. Okay? So again, we're talking about vertical displacement. So vertical, gravity is involved with vertical movement. So we want, again, the formula that includes gravity. So displacement is equal to initial velocity multiplied by the change in time plus 1/2 times gravity times change in time squared. Okay? Displacement is what we're solving for, so we're ready to go. Formula is ready. Initial velocity, okay, needs to be the vertical initial velocity, which again is 40. The change in time in this situation is going to be the 4 seconds. So 4 plus 1/2, so 0.5, multiplied by g, which is -10, multiplied by the time, which is 4, squared. Okay, so we're going to figure out that vertical displacement at 4 seconds. So there's 0 seconds, 1, 2, 3, 4 seconds. We're getting the height at the apex. That right there. Okay, so we're going to figure out the maximum height of this projectile. Okay, so an easy way to do this with the formula, we've already typed it in. Instead of the 2 seconds like we had right here, replace that with the 4. And then go across where you have the other seconds written in again, time again, but replace it with a 4. And now you get your answer, 80. And again, we're dealing with that height, that displacement, so my units are in meters. Now, the next two questions, questions 5 and 6, it asks for you to predict. All right, predict. That means no calculations. I want you to look at the diagram, strictly looking at the diagram. Okay, so we want vertical displacement at 8 seconds. All right, so vertical displacement, where's 8 seconds? Well, it was 0, 1, 2, 3, 4, 5, 6, 7, and 8. 8 seconds, right there. What's its vertical displacement? Well, it's a good question. Go to question number 6. Okay, we want the vertical displacement at 6 seconds. Okay, so vertical displacement 6 seconds. Well, where's 6 seconds? Right there. What's the vertical displacement for 6 seconds? All right, what did I ask me for? Vertical, we're talking about height. So the height at 6 seconds. Just by looking at the diagram, it should be fairly easy to identify what that value would be. Because if you notice 6 seconds and 2 seconds, projectiles at the same height because we're dealing with that parabola, that mirror image. So those two are at the same height, 2 seconds and 6 seconds. So what is my prediction for my vertical displacement at 6 seconds? Well, we've already calculated the height at 2 seconds. There we go. We're going to predict it's 60 meters. All right, it's the same height as, no, at 2 seconds, sorry. It's the same height at 2 seconds, and we've already calculated the 2-second value, so we know it's going to be 60. Okay, how about 8 seconds? Let's go back up to question number 5. 8 seconds. Well, if this is 60, this was 80, what's that height right there? It's 0. Because it's the same height at 0 seconds. Okay? When it's at its reference point. Now, questions 7 and 8, I want you to actually calculate those. Okay? I want you to calculate the vertical displacement at 6 seconds. And I want you to calculate the vertical displacement at 8 seconds. All right? And I want you to do those calculations so you can see for yourself, prove to yourself that indeed those formulas do produce those answers. Okay? So vertical displacement, we're talking about vertical, we need gravity. So this is the formula we're going to use because it has right here gravity. All right? Solving for displacement, so our formula is already set up to solve for displacement. Vertical velocity, all right, so we need the vertical initial velocity, which is 40. The change in time of 6 seconds, plus 1/2, so 0.5, multiplied by g, the -10, multiplied by t, the 6 seconds, all right, squared. Plug those values in. Again, with a calculator, all you have to do, the same formula is already in there, just enter the 6. And there you go, 60. We just confirmed that our prediction of 60, whether you put in 2 seconds or whether you put in 6 seconds into that formula, you get the same answer, 60 meters. Put in 2 seconds, put in 6 seconds, they still have the same height, 60 meters. This only works because gravity is negative. If you put a positive value for gravity, it does not work. Okay, over here, vertical displacement 8 seconds. All right, let's give it a try. Again, we're dealing with vertical, so we need gravity. So we're going to use the formula that contains gravity. Right here, that 1/2 gravity, change in time squared. Okay, this time, again, vertical, so we need the vertical initial velocity, which is 40. Time is 8 seconds. All right, that's our change in time there is 8 seconds. Add that to 1/2, 0.5, multiplied by gravity, -10, multiplied by 8 squared. Okay, plug those numbers in, 8. So 40 multiplied by 8 plus 1/2 multiplied by -8 squared, answer 0. And that is what we expected because that is what we see in the diagram. 0 seconds and 8 seconds are both at the bottom at the reference point, 0 meters. All right, the next two questions are completely different. Okay, these are asking for horizontal displacement. Okay, it's asking for the horizontal displacement. At 3 seconds. Okay, so go up to our diagram. What is it asking for? Well, here's the projectile at 3 seconds, but I just want the horizontal. I don't want the vertical. I want the horizontal. So the horizontal, 3 seconds. That horizontal piece, how long is that? That's what I'm trying to solve for. Okay? So, to solve for that, horizontal movement. Is horizontal movement affected by gravity? No, it's not. So I do not want to use that formula because that has gravity. Horizontal movement is unaffected by gravity. So I'm going to use that formula. Okay? So we've got velocity is equal to the displacement divided by the change in time. Okay? Displacement that's our question. If displacement's our question, we need to rearrange that formula. So, magic triangle. Delta D on top, delta T and V on the bottom. Delta T is the question. So delta D is the question. So delta D equals. Cover that with your finger in the triangle. You're left with V and delta T side by side. V multiplied by delta T. You have rearranged your formula to solve for displacement. Now notice, we're talking horizontal, which means we need the horizontal velocity. If you notice, it's a constant velocity, so it doesn't matter what time we pick it from, it's going to be the same number. So that horizontal velocity is going to be 16. The time, the change in time, right there, given to you in the problem, 3 seconds. 16 times 3 gives you 48. Now displacement, that horizontal displacement there, we're solving for displacement in meters. So 48 meters is how far horizontally the ball has gone in 3 seconds. Okay? Alright, last one, you're going to calculate horizontal displacement again, but this time when the projectile hits the ground. Okay? So, horizontal displacement, but when it hits the ground. What do we know about when it hits the ground? Looking at your diagram. Where does it hit the ground? Right there. What do we know about that moment? It's 8 seconds. So, information provided. The change in time is 8 seconds. The question we're looking for is displacement. What do we know about the horizontal motion? We know in the horizontal, our constant velocity is 16 meters per second. Okay? So again, our formula, displacement's the question, so we're going to rearrange it just like we did over here. Using the triangle, we get delta D is equal to the velocity multiplied by the change in time. So, plug in those values. Velocity, 16, multiplied by 8 seconds this time. 16 multiplied by 8, calculator says 128. 128 meters, that horizontal. So from 0 to 8 seconds, that's going to be 128 meters. Okay? Back side of the worksheet, very similar to the front side, with one key difference. This right here is our reference point. Okay? So, when we're dealing with that as our reference point, numbers going up, displacements are going to be positive. Anything going below that, displacements are going to be negative because you're going below the reference point or above the reference point. Okay, so be careful of that. So pay close attention to what you're actually solving for in these. But you're going to set up the same way. Alright, you're going to label these. So T, this is equals 0, this is 1 second, 2 seconds, 3 seconds, 4 seconds. What happens at 3 seconds? That's the apex. 5 seconds, 6 seconds, 7 seconds, 8 seconds. Okay, so have those numerically labeled so that you can fill in your data table. Here are your initial values right there. There's your formulas. Don't forget to pay attention to where gravity is. Alright, and that should get you going, get you started. Good luck.